Welcome to lesson 4.8, which is all about switching the quadratic relation between the standard form and the factored form. So we'll look first at switching from factored form to standard form and how to do that. And then we'll look at how to go from standard form to factored form. So we're going to start off just recalling what our forms are. So recall that the factored form of a quadratic relation is in this following form: y equals a, and then in brackets we have x minus r times x minus s, where r and s are going to be our x-intercepts. The standard form of a quadratic relation is written in the form y equals ax squared plus bx plus c. Remember, c is our y-intercept, and a, if it's positive, tells us the parabola opens upwards, and if a is negative, it tells us our parabola opens downwards. So we can get some good information from these forms, and now we're going to learn how to flip between them. So to convert the equation of a quadratic relation from factored form to standard form, we're just going to follow these steps. We're simply going to expand the factored form using the distributive property, and then we're going to simplify by collecting like terms to the standard form of a quadratic relation. So we're going to use an example here. We want to rewrite y equals x plus 2 times x plus 1 in standard form. Now we can see here we've got two binomials. This is in factored form. So we've seen this before in the early lessons of Unit 4, where we use FOIL, or the distributive law, in order to distribute all the terms in our first brackets with all the terms in our second brackets. So remember FOIL, we multiply our first terms, then our outside terms, then our inside terms, then our last terms. So when we do this, I just rewrote the equation there, and I've written the expanded form below. And so what we'll do is we'll do x times x. Those are our first terms. That's going to give us x squared. Then we do our outside, which is x times 1. So that's just going to give us 1x. We can just write it as positive x. Then we do our inside terms, 2 times x. So we've got plus 2x. And finally, our last terms, 2 times 1, which is 2. So we now have our equation y equals x squared plus x plus 2x plus 2. And we're almost in the standard form. Our last step here is just collect our like terms, our x's. So we're going to have y equals x squared plus 3x plus 2. And now the quadratic relation is in standard form. So as you can see, we've just gone from factored form to standard form just by using the distributive law and then collecting our like terms. We're going to take a look at one more example of this. So this example, rewrite the following in standard form: y equals 3 times x plus 1 times x minus 5. So the only real difference here is that our a value isn't 1. We've got an a value of 3. But we still follow the same process. You have two options. You can either use the distributive property and multiply 3 by x plus 1, and then multiply the product of that by x minus 5. Or you can leave the 3 to the end and just do what we did in the previous example: multiply our two binomials first and then multiply it by 3, which is the option I'm going to do. So I've left the 3 alone there. It's outside brackets. Inside my brackets, I'm going to use FOIL. So x times x is x squared. X times negative 5 is negative 5x. 1 times x is positive x. And 1 times negative 5 is going to give us negative 5. Now I'm going to collect my like terms within the brackets. So 3 times x squared minus 4x minus 5. And now I'm going to distribute the 3 as well. So the 3 will have to multiply with all 3 terms inside my brackets. So 3 times x squared is going to give us 3x squared. 3 times negative 4x is negative 12x. And finally, 3 times negative 5 is negative 15. And now the quadratic relation is in standard form. So just to recap, if we go from factored form to standard form, just use our distributive property, multiply everything through, collect your like terms, and then you have your standard form. So how about if we want to go from standard form to factored form? Well, to change a quadratic relation from standard form to factored form, we're going to follow these steps. Step 1 is we're going to factor out the coefficient a. So if there's a number in front of x squared, and I'm just going to go up here to this example, we can see a in this case is 3. So if we did want to change this from standard form to factored form, we would have to factor out the 3 from all of these terms first. Once we've done that, then we want to factor the trinomial that's left inside the brackets. Once we've factored it down to 2 binomials, or a binomial squared if that's the case, then we're in factored form. So let's see this in action. We want to rewrite the following equation, quadratic relation, in factored form. So y equals x squared plus 5x plus 6. And as we can see, in this case, we don't have a coefficient in front of the x squared. It's just 1. So we don't have to factor anything out. So what we're left with is going straight to step 2, where we're going to factor our trinomial. So remember, when we're factoring our trinomial, we want, and this is a simple trinomial, we want 2 numbers that multiply to 6 and add to 5. So just think about all the factors that you've got, are all the numbers that can multiply to 6. We've got 1 times 6, and we've got 2 times 3. So 1, 2, 3, and 6 are all factors. We look here, well, 2 and 3 are going to multiply to 6 and add to 5. So those are going to be the numbers we use. So we're just going to factor it down. Y equals x plus 3 times x plus 2. Now we're in factored form. So let's see one where the coefficient in front of the x squared, or a, is not 1. So rewrite the following quadratic relation in factored form. Y equals 3x squared minus 9x minus 12. Well, step 1 here, we're going to factor out a 3. Why? Because that's the number that's in front of our x squared. So we need to factor that number out from all 3 of these terms. So when we do that, 3x squared divided by 3 is just going to give us x squared. 3 divided by negative 9x is going to be negative 3x. And negative 12 divided by 3 is going to be negative 4. I think I said it backwards here. That should be negative 9x divided by 3, not 3 divided by negative 9x. So negative 9x divided by 3 gives us negative 3x. Negative 12 divided by 3 gives us negative 4. So now we factored out 3. Our 3 is still here. It's just outside the brackets. Now we want to try and factor the trinomial that's inside the brackets. So x squared minus 3x minus 4. We now have a simple trinomial again. And we know the process for this. We need 2 numbers that multiply to negative 4, but add to negative 3. Also, if we remember our patterns, since c is negative, negative 4, That means that we have one positive number and one negative number. And since b is negative, negative 3x, that means that our larger number has to be negative and our smaller number has to be positive. So, two numbers that multiply to negative 4 and add to negative 3. Well, 4 and 1 will work, but the 4, it's the larger number, has to be negative. So it's actually negative 4, positive 1. So we come down here. 3x minus 4, x plus 1. And we've now factored our quadratic relation, and we are in factored form. With a of 3, our x-intercepts are at x equals 4 and x equals negative 1. I hope you enjoyed that. Tune in next time when we learn how to switch between other forms of the quadratic relation. Let me know if you have any questions. Thanks for watching.